Next topic is related to the camera calibration, which is related to the projection just now. So we're going to learn about this camera calibration process, or we also known as a camera resection terms. Okay, calibration helps determine the intrinsic and extrinsic parameter to ensure accurate mapping from the 3D world to the image. So it is a process to help, okay, to map correctly from the 3D world to the image. Okay, so it will estimate the parameters of a lens and image sensor of an image or video camera. So this parameter to correct for lens distortion measure the size on an object in the world unit. So this is a process or determine the locations of the camera in the scene. So this task is normally used in machine vision to detect and measure object correctly, because if it is not calibrated, it may have a different values of measurement, something like that. Okay, they are also used in robotics for navigation system and 3D scene reconstruction. So this is example of the distortion here. You can see from the image, it's just like the fish eye. Yeah, so you can see that it does not really straight over here. So this is kind of example of distortion. Okay, so there are four main types of camera distortion. So we're not going to learn everything. We just need to learn only a few things, maybe two. So the first one is under the radial distortion, and the second one is under tangential distortion. Third one is thin prism, and the last one is perspective distortion. So for this particular radio distortion, right, they are also known as barrel distortions, pin cushions, and moustache distortion. So you can see this is an example of the effects of distortions. So the image is not really as straight as like we can see clearly, compared to when you have a lens, which can cause this problem. Right, for the tangential, the output of the image can be like this, and for the perspective distortion is normally like a perspective one. You can see that this building is a bit slanted and like to be collapsed, like to collapse, right? So it can be adjusted back to make it straight like this. So this is a kind of types of distortion that we are going to learn today. So the first one is about the radial distortion. So this is same type for the S3. They're also known as these one specific names. All right, so this is radial distortion. You can see that this is just like this barrel distortion. You can see that it's just like a barrel there. And then this is a normal image, no distortion. So you can make the image to be straight by calibrating and understanding the concept of their distortion coefficients, because this is a fixed formula given for the radial distortion. So you can calculate the value of the distortion, distorted x and y based on this parameter. This is the what I call it? The formula. So x distorted is the x, y here is the x and y here is the original locations, and then this is going to be distorted based on these coefficients. So 1 plus k1 r2 plus k2 r4 plus k3 r6. So r is equivalent to x2 plus y2. This is the formula, right? So if if k r2, then you have to double up the numbers over there. All right, so this is the value. So let's look at example here. Given the normalized image coordinates x equivalent to 0.1 and y is equivalent to 0.2, and the radial distortion coefficient k 0.1, so there is nothing here and nothing here. Compute the distorted image coordinate x distorted and y distorted using the radial distortion model. So this is the model for the x distorted and y distorted. We just use the same formula, put one by one here, here. So you have to understand the R2 is equal to X2 plus Y2. So you have the X and R, okay, X and Y, sorry. Then you can calculate the value of R2. Then you can put all the value inside the formula. You can find the X distorted and Y distorted. So this is going to be the value of the distorted point, okay. So this is another exercise. You can look at the exercise and understand the concept, right? So this is actually a bit extra. on the question itself. It does not only you just need to understand the concept because this is K1, right? So you have to use which is the formula or the equation that's still left over there. Right, you can try yourself over here. Okay, next is the tangential distortion, right? So this distortion is related when the lens of the camera being utilized, which is not perfectly aligned with the image plane. So this is the one. So you can see that this is the output for the tangential distortion. So the tangential distortion coefficient model in this type position, and the points are denoted as this one. This is the model. So you need to know again the r square is equal to x square plus y square, and the rest are the values that you need to find out. Okay, let's look at the questions here. A point is normalized in image coordinate and given as, and the tangential distortion coefficient given as below. So you are given P1 and P2. This is the point. So you have the XY point, you have P, okay, P1 and P2. The rest is just calculated based on the R. R is equivalent to X squared plus Y squared. And then you can count, put all the values inside the formula and calculate all one by one. So eventually you can find the distorted value x distorted and y distorted from the calculations. So this is the details on the calculations for the tangential. All right, so finally you can get the x distorted and y distorted 0.2 and 0.3. So more or less for the topics of this particular distortion, right, for radial and tangential, the calculation is straightforward because you need to understand how to use the formula only. All right, that's we are going to cover only two for the distortion. Okay, so you have to answer the questions for the quiz given in Microsoft form. Thank you.